Yeah, children, we'll try to analyze this advanced paper, paper 1. In this, I thought I will tell you something important here. Yes, paper is, for some people, paper is moderate, for some people it is moderate to difficulty, whatever be it. But if you go through the paper, there are few questions which are so simple. I think that everyone can and everyone should answer these kind of questions. Well, it's all about not just about answering all the questions that are given in the question. Sometimes there are few questions which will definitely give you a positive mark, and you should identify those kind of questions and then go about those questions rather than falling into the trap of solving all the questions and getting a negative mark. There are few questions which will definitely give you positive mark, and today I am going to just touch upon those questions which I feel every student who has prepared for advanced examination should be able to solving these questions for sure in the examination. One such question is this vernier calipers question, a question based on vernier calipers. Now, most likely all of you would have read the question. The question is here, and question says that we are trying to measure the diameter of a test tube, and two figures are given in the question. If you can see carefully, the first figure corresponds to the vernier caliper, diagram of a vernier caliper in which there is no measurement taken yet. So just before taking any measurement, this is the situation. Now once you put the test tube to find out the diameter of the test tube, the diagram is given over here. Now if you observe these two diagrams, in fact the first diagram, you should be able to understand that there is no zero error to the given vernier calipers. There is no zero error because the zero of the main scale is exactly coinciding with the first division over there, or the 0th division of the vernier calipers, and there is no zero error. So problem has been made very simple for us. There is no botheration of finding zero error and then later on using that in the calculation. First thing is that one. Second thing, if you observe the main scale, in the main scale there are 10 divisions are there, and 10 divisions corresponds to 1 centimeter. So obviously the value of one main scale division, the value of one main scale division, the value of one main scale division according to the diagram that is given to us. Now there are 10 main scale divisions. If you can observe carefully, you have 10 main scale divisions there. 10 main scale divisions is equals to 1 centimeter. Therefore, one main scale division in this particular case is 0.1 centimeter. If you observe this carefully, one main scale division is 0.1 centimeter. Now, not only that, which is equal to 1 millimeter. Now, if you observe this carefully, in the vernier caliper scale that is given to us, again there are 10 divisions, but those 10 divisions, the 10 divisions of the vernier calipers are ending at 0.7. That means 10 divisions of vernier calipers are equal to 0.7 centimeters, or 7 divisions of the main scale. So 10 vernier scale divisions, according to the diagram, 10 vernier scale divisions are equal to how many? 7 main scale divisions it is given. Looking at the diagram, very easily you can understand 10 vernier scale divisions are equal to 7 main scale divisions. So 10 vernier scale divisions are equal to 7. Each division is 1 millimeter, so that is 7 millimeters, or one vernier scale division is equals to 0.7 millimeter. So it's very easy to gather this information from the diagram. One vernier scale division value is equals to 0.7 millimeter. Now from here you can solve the problem in two ways. Directly, if you remember the formula, you can use the formula and then you can substitute in the formula and do it. So first let me try to solve this problem using the formula. Formula is total reading using a vernier calipers would be main scale reading plus n into LC, where LC stands for the least count and n is the vernier coincidence. Now what is the formula for least count of a vernier calipers? It is 1 MSD, main scale division, minus 1 VSD. 1 MSD is 1 millimeter, and 1 VSD, vernier scale division, we got it as 0.7. So the value would be 0.3 millimeters is the least count of the given vernier calipers. And main scale reading. Main scale reading is obviously the reading on the main scale. no rocket science there. So the value of the main scale you have to take, and how do we take that one? The main scale reading is the reading on the main scale just before the 0 of the vernier. So this is a 0 of the vernier, just before 0 of the vernier, it is 1 over there. So main scale reading from the second diagram is equals to 1 plus. Which division of the vernier calipers is coinciding exactly with the main scale division? If you can observe carefully, the first division is coinciding. So from the diagram, the value of n or the vernier coincidence is equal to 1 and least count is 0.3. So overall it is 1 plus 0.3, which is 1.3 millimeters, or it is 0.13 centimeter. So it's a simple problem. You can see the answer is 0.13 centimeter. Using the formula, you can solve the question like this. I hope it is clear. Or otherwise also, if you don't want to use the formula, and very simply you can gather from the second diagram. If you see the second diagram carefully here, you can understand the second division. Each division is 0.7, as I did over here. Each division value of the vernier scale is 0.1, and our diagram shows that the this line is exactly in coincidence with this. This line is exactly in coincidence with, up to here it is 1 millimeter, and this remaining portion if you take it as some y, remaining portion if you take it as y, then this 1 plus the remaining portion is nothing but this whole thing, that is 1 millimeter minus 0.7, it will be 0.3. So y value will be 0.3. So total value will be 1 plus 0.3. Even that way you can do it. It would be 0.13 centimeter or 1.3 millimeter. So that's two different ways of doing the same problem. Of course, the same method, but you can solve this question like this. Then we'll go to the next question, which is again an easy question. All of you, according to me, should be able to solve this. Anyone giving this advanced examination should be able to solve this kind of a questions. So question says length is given, breadth is given, thickness is given, and those values are given over there, and they are asking us to find out the volume to the correct significant figures. Okay, according to the question, the length is given as, length of the strip is given as 10.5 centimeter. Now in this, you can see the number of significant figures are 3, even though you have 0 over there. Straight away from the rules of significant figure, you can say that the number of significant figure in the given value is equals to 3. So significant figures are 3 here in case of length. And in case of breadth that you have over there, breadth is given as 0.05 millimeters is given, and the number of significant figures here. Here, yes, number of significant figures are 3 because 3 digits are there, but here also you may feel that there are 3 digits over here and the significant figures are 3, but no, because the digit that is given just before the decimal is a 0 digit. It is 0, it is not greater than 0. So this is not significant, this is not significant in this particular number, going by the rules that the number of significant figures are 1. In breadth, the number of significant figure is 1. And in the thickness that is given in the question, 6 micrometer is given. Now after decimal there is a 0, and before decimal there is a non-zero digit is there. Therefore the number of significant figures here is 2. So number of significant figure is 2 in case of thickness. And we just want volume, and all of us understand that volume is nothing but length into breadth into height or thickness in this particular case. And when you do so, you will get some value over here. That value you have to round it off to a value which is having a significant number which is least among these three things. The least significant number among this one is this, so you have to round it off to one significant digit. So round it off so that the final digit, significant number, will become equal to 1, and there is no need of multiplying also and wasting time. If you see all the options that are given over here, first option is giving you number of significant figures as 2. There are 2 significant figures in the first option. In the second one there are 3 significant figures. In the third one again there are 2 significant numbers. In the fourth one there is only 1 significant, and we need to round it off to 1 significant figure. So don't even do the problem. The answer to the question would be the last option, because in the last option there is only 1 significant digit is there, and hence the answer to this question is D, we don't need to waste time multiplying and solving all that, no need. Directly you can give the answer there. It is D option. I hope this second question is also quite simple to solve it. It's all about choosing the questions. Don't just be in a hurry to solve all the problems. Yes, it is good if you can solve it, but then sometimes it is always advised not to go with the questions which may give you a negative mark. If you are not quite sure about solving the questions, then don't touch all the questions. Choose something which is very important in the beginning. So 2 questions, very simple one. Let's take one more easy question that came in the paper, in paper 1, Sunday morning. This question is again very simple. Question says there is a cube of unit volume and this many number of protons are there, this many number of photons are there, and the frequency of a photon is 10 raised to 15 hertz. Now these photons, obviously when a photon is there, that photon will be having energy and we can definitely calculate the energy. Now question says the energy of all these photons is, there is an electromagnetic wave which has got the same energy as these photons. Combinedly these photons have some energy, same is the energy of the electromagnetic wave, and then he is asking us to calculate the amplitude of the magnetic field. This is straight formula based question. Each one of you, while preparing for your mains only, you would have done these kind of problems. So according to the question, how many number of photons are there? Number of photons are 35 into 10 raised to 7 number of photons are there. The frequency of each photon is given as 10 raised to 15. Therefore, what is the combined energy of all these photons? The combined energy of all these photons, energy of each photon is h nu. You have n such number of them, so n h nu is the combined energy of all the photons put together, and number of photons are 10 raised to 15. Planck's constant is given in the question as 6 into 10 raised to minus 34 joule second. Frequency is given as 10 raised to 15 hertz is the frequency that is given. So let us simplify this one. This is 6 into 10 power 15 and 10 power 15 is the frequency, 30, so that becomes 10 raised to minus 4 is joules is the energy. Now this is also equal to, according to the question, this is also equal to the average energy. He is telling if you can assume, not that this is equal to, he is telling if you assume that the total energy of all these photons is same as the average energy of the electromagnetic wave. Now what is the average energy of an electromagnetic wave? Average energy of an electromagnetic wave is B naught square divided by 2 mu naught. This is the average energy of an electromagnetic wave in terms of the magnetic field, in terms of the amplitude of the magnetic field. Now according to the question, this whole thing and this are same, 6 into 10 raised to minus 4. So from this one, B naught square is equals to 2 times mu naught. Mu naught is given in the question itself as 4 pi into 10 raised to minus 7 into 6 into 10 power minus 4, and therefore B naught is equals to 2 into 4 into 22 by 7 into 6 into 10 raised to minus 11. Now we will solve this. You will simplify this one and take root of this one. This turns out to be close to 22.9 or approximately 23. Now it's up to the people who gave the paper to give a range of answer over here. If pinpointedly you cannot say 22.9, it would be approximate. So maybe they will consider for 2 digits, something like that. So finding the square root of this one, it would be close to 23 or 22.9 you can take, 9 or 9.9 or 9.8. That would be the answer to the question, a simple one. Just find the energy, equate that energy to the average energy of an electromagnetic wave, which is B naught square upon 2 mu naught, and do this calculation, and that's all. Substitute, you will get the answer. This is also a third question where easy question where everyone should get positive mark for this particular thing. Let's take one more question, similar kind of a question that is given in the paper. This is quite a good question, easy question, every student should be able to do it. Firstly, you will understand that there are, as per the question, there are 2 plates are there, P and Q are the plates initially. And going by the question, you will understand that the temperature of P is more than temperature of Q. Obviously, there would be radiation going from P to Q. This is at high temperature, this is at low temperature, P is at high temperature and Q is at low temperature. Therefore, you will see that there is radiation going from P to Q, the radiation would be going. And that value is given as W naught, and going by Stephen's law, you can say that W naught is equals to Stephen's constant sigma into Tp into Tp power 4 minus Tq power 4. So this is the information, initial information that is given to us, where Tp stands for the temperature of this slab, Tq stands for the temperature of this one. Now what they are doing, they are trying to introduce two more slabs, identical slabs in between these two plates. And after some time, when they attain the steady state, he is asking, and according to the question, this second plate will be radiating with this one and this one only. The third one is in communication with the second one and the last one. So that is also there. That means there is no radiation going from P to this third one or P to fourth one directly or second one to fourth one directly, nothing of that sort. They are communicating only, there is a transmission of heat only from one plate to the other plate. There is a transmission of heat taking place. So under steady state, whatever the radiation is there, whatever the exchange of radiation is there between P plate and the second plate, I call it as plate 2. I call it as plate 2 and let this be plate 3. So the radiation that is going from plate P to 2 should be same as the radiation going from plate 2 to 3, should be same as radiation going from plate 3 to Q, because they are under steady state. This kind of a thing is happening. So what does it mean? So if I write equations for these things, then you will get Ws is equals to sigma T to the power of Tp to the power of 4 minus T2, where T2 is the temperature of the second plate, to the power of 4. Similarly, Ws should also be equal to sigma T2 to the power of 4 minus T3 to the power of 4. Ws is also equal to sigma T3 to the power of 4 minus Tq to the power of 4. So because all of them are under steady state, the radiation is also same. If you observe these equations and try to add this equation, this equation, this equation, if you add them, you will see that these two will get cancelled, these two things will get cancelled. So this is Ws is nothing but 3Ws is equals to sigma Tp to the power of 4 minus Tq to the power of 4. So that means 3 times Ws is equals to this sigma Tp to the power 4 minus Tq to the power of 4 is nothing but W naught is W naught. We want the ratio W naught by Ws, therefore W naught by Ws is equals to 3. A very simple numerical that is given in the question. Answer to the question should be 3. Very easy. So these kind of questions will always be there. As a student, you should be able to identify, you should have a very good eye, identify these things, substitute them and get a positive mark. Some more questions are there. Other faculty will come and explain the other questions. Thank you for hearing to me. Thank you very much.
So, good morning students. We are discussing paper 2. Some of the questions, not all questions. Okay. So, this is one of the questions given in paper 2, JEE Advanced this year. Okay. What I have observed is questions are framed well, but not that tough. Okay. 2 or 3 questions we have to get some idea, but remaining questions are not that tough. Okay. So once you prepare well by using concepts and conceptual study, once you can do, you can answer most of the questions. So this is one question. 2 coaxial conducting cylinders of same length P with radii root 2r and 2r are kept as shown in the figure. The charge on the inner cylinder is Q and the outer cylinder is grounded. The annular region between the cylinders is filled with dielectric constant K equal to 5. Consider an imaginary plane of same length P at a distance r. Okay, the plane is parallel to the axis of the cylinder. The cross-sectional view of this arrangement is shown in the figure. Ignoring edge effects, the flux of the electric field through the plane. Epsilon naught is permittivity of free space. Okay. So once we see the cross section, cross section is a circle and inner cylinder has a radius root 2r, outer cylinder 2r. Okay. So this plane cuts this inner cylinder at a distance r. Okay. And charge on the inner cylinder is q, outer cylinder is earthed. Okay. So what is electric field inside the inner cylinder is 0. So there is electric field only between inner cylinder and outer cylinder. And what is charge per unit length on the inner cylinder is q by L. Q is the total charge given. So q by L. L is length of the cylinder. And what is electric field somewhere here? If I consider some point here, this is the plane at a distance y, width is dy. Okay. So electric field at that point will be in this direction. So if this angle is theta and area vector is in this direction, what is area vector is L dy. This is L and this is dy. Okay, theta, and this is small r, and electric field is lambda by 2 pi epsilon naught r into k, dielectric constant. Okay. And angle between area vector and electric field is theta. So what is flux through this small area is EA cos theta, E dA cos theta. That is how much? Lambda by 2 pi epsilon naught k r into L dy into cos theta. Okay. Lambda L is q that we can put. Okay. That is flux through this small area. Then how to find flux from here to here? There is no flux. Okay. There is flux only from here to here and here to here. We can find flux from this point to this point through this area, and we can double it. Okay, through this also it will be same. So if I integrate this, as theta varies from, what is this angle? This is root 2r, this is r, so this is 45 degrees, and this is 2r, this is r, that is 60 degrees. So what are limits of integration? 45 to 60. You have to convert to radian. Okay, radian and right. And now if I integrate this, what do you get? What is tan theta? Is y by capital R. Y is equal to r tan theta. So what is dy? R secant square theta d theta. Okay. So in place of dy you put r secant square theta d theta, and small r is nothing but capital R secant theta. Okay. So in place of small r you put capital R secant theta, and in place of dy r secant square theta d theta. Okay. So secant theta cancels, cos theta cancels, r also cancels. So this you have to integrate as theta varies from 45 to 60. Then what do you get? Lambda L is q. So q by 2 pi epsilon naught k into 15 degrees Celsius. If I put limits, okay, 15 means pi by 12. Okay. If I convert to radian, okay, that's what it is. K value they have given, that you can substitute into 2 you should do, because this part also flux is same. So that's what you should do. This is one method, other method also will be there. Now this angle is 15 degrees. Okay. So if you consider entire circle, okay, it is 360 degrees. So through 360 degrees angle, what is flux? Is q by k epsilon naught. 15 degrees angle, what is flux? That is 15 by 360 into q by k epsilon into 2. This part and this part. That is the answer. Okay. This is another method. We can do like this also. This is by integration. Okay. Entire flux, if it is 360 degrees, q by k epsilon. If it is 15 degrees, how much? That is 15 by 360 into q by k epsilon. You can do like this also. Once you solve this, you will get that out. Okay. So next question we'll see. Now as shown in the figure, these are two springs, okay, are connected at the midpoint. The rod as shown in the figure F1. On the other hand, both the springs are connected. Oscillate angular displacement, and then frequency of oscillation is F2, ignoring gravity and assuming motion only in the plane of the diagram. The value of F1 by F2. Now if springs are connected here, angular frequency is omega 1. If they are connected like this, omega 2, then find omega 1 by omega 2 he is asking, or F1 by F2. Ratio of frequencies and angular frequencies will be same. How to find angular frequency? Once it is oscillated like this, let us say it is displaced by some theta. Theta is very small angle, okay, rotated by theta. Then this elongates by L by 2 theta, this elongates by L theta. So here what is spring force is KL theta, here k into L by 2 theta. So what is net torque about this point? That is k L theta into L plus k L by 2 theta into L by 2, that is k L square by 4 theta. So this is net torque. So this is nothing but 5 k L square by 4 into theta. So what is angular frequency? Root of coefficient of theta by I, that is root of 5 k L square by 4 I. I is ml square by 3, we can substitute, but not necessary anyhow because it is asking ratio, and if it is same rod, I anyhow do not change. Now in this case, what is torque? Both the springs are attached here only. So torque due to this is KL square by 4 into theta, the second term will get, second term into 2 will get, that's. So KL square by 2 into theta. So what is omega 2? Is root of KL square by 2 I, that's. Now take ratio. Omega 1 by omega 2 is 5 by 4 by 2. So root 5 by 2 will get, okay. Answer is C. If gravity is also considered, then mg into, that will act at like center of mass, okay. So mg into L by 2 theta, another term will get minus here, okay. But ignore gravity, so question has become simple. You can do by energy method also, okay. Next, this question. Two identical concave mirrors, each of focal length f, are facing each other as shown in the diagram. Focal length is much larger than the size of the mirrors. A glass slab of thickness T and refractive index N0 is kept equidistant from the mirrors and perpendicular to their common principal axis. A monochromatic point light source is embedded in the center of the slab as shown in the schematic diagram. For the image to be formed and sits. Now this is a question from H.C. Verma, not exactly, but idea is from H.C. Verma, okay, it is there. Now two mirrors will be there for same focal length, object is kept in between, distance is d, find d so that object and image coincides. One is, this should be common focus. If object and image has to coincide, always it should be image is here, then this should be either focus or center of curvature of both the mirrors. That means d can be either 2f or 4f. Now this question is extension of this concept, okay. That is here he has kept another slab, that means there is a shift, okay. What is shift? If I consider reflection here, okay. First of all refraction, then reflection. What is shift? We can consider half the slab, then shift is t by 2 into 1 minus 1 by n0, okay. Now this is object for refraction, its image will act like object for next reflection. So image is somewhere here and this is shift, okay. So this should be at focus of this or center of curvature of that. Similarly for that also, the object here, the image here should be either at center of curvature or focus. Now if this is at center of curvature, then which of the following distances between the two mirrors is correct, okay. If this is focus, okay, so this is f, this is f, okay, then what is distance between two mirrors is 2f plus double this, okay. And if it is center of curvature, if this image is at center of curvature of this mirror or this image is at center of curvature of that mirror, then this distance is 2f, this is 2f plus twice shift, okay. So one answer is this can be focus of this and this is focus of that, or this can be center of curvature of this and that is also center of curvature of that. Then distance will be 4f plus, if this is x, 2x. Other case, if these two are focus of foci of those two mirrors, then it will be 2f plus 2x. So these two are the possible answers, okay. 4f plus 2x means 4f plus 2 into, means 2 cancels, will get t into 1 minus 1 by n0. Next is 2f plus t into 1 minus 1 by n0. So A and B are the answers, okay. Now a hydrogen atom initially at rest in its ground state absorbs a photon of frequency nu1 and ejects the electron with a kinetic energy of 10 electron volt. The electron then combines with a positron to rest at rest to form a positronium atom in its ground state and simultaneously emits a photon of frequency nu2. The center of mass of the resulting positronium atom moves with a kinetic energy of 5 electron volt. It is given that positron has the same mass as that of electron, considered as a Bohr atom in which the electron and positron orbit around the center of mass. Considering the no energy loss during the whole process, the difference between the photon frequencies, okay, photon energies. Now initially frequency of the photon is nu1. So if its energy is E1, that is h nu1, once it falls on a hydrogen atom in ground state, electron gets ejected and it acquires a kinetic energy of 10 electron volt. So what is energy of the photon? E1, that is nothing but energy required to knock out the electron plus remaining energy appears as kinetic energy for electron, that is nothing but 13.6 plus 10, that is 23.6 electron volt. Okay. In the second case, this 10 electron volt is the frequency of the photon, energy of the photon that falls on the electron. Okay, this electron, 10 electron volt electron, it combines with a positron to form a positronium atom. Positronium atom is an atom where electron and positron revolve around common center of mass. Then we have to take reduced mass. Okay, then energy in the ground state will become half. Energy is directly proportional to mass of electron. Okay, and if masses are comparable for nucleus and the orbital electron, then both of them move around their common center of mass. Then in place of mass of electron, we will get reduced mass mu, that is m1 m2 by m1 plus m2. In this case, positronium atom, mass of positron and electron are same, so m into m by m plus m, that is m by 2 will get. So energy in the ground state will become half. Okay, that is 13.6 by 2, that is minus 6.8 will get. Okay, so what is energy of the electron now? What is initial energy? 10, that is equal to, once positronium atom is formed in ground state, what is its energy? Minus 6.8. Okay, plus the center of mass is not stationary. Okay, center of mass is also moving with what energy? 5 electron volt. So plus 5 plus a photon is emitted of energy E2, that's all. Okay, so E2 you have to find. What is E2? It is 16.8 minus 5, that is 11.8. So what is E2 minus E1 or E1 minus E2? 23.6 minus 11.8. Okay, that is also 11.8 I think. Okay, 11.8 into 2 will be this. Okay, so answer is 11.8 electron volt. Next question. This is from thermodynamics. Okay, the left and right compartments of a thermally isolated container of length L are separated by a thermally conducting movable piston of area A. The left and right compartments are filled with 3 by 2 and 1 mole of an ideal gas respectively. In the left compartment, the piston is attached by a spring with spring constant K and natural length 2L by 5. Thermodynamic equilibrium, the piston is at a distance L by 2 from the left and right edges of the container as shown in the figure. Under the above conditions, if the pressure in the right compartment is KL by A alpha, then value of alpha is. Now let us say pressure here is P1, here P2. Spring is, what is length of the spring? Now L by 2, natural length is 2L by 5. So what is elongation? L by 2 minus 2L by 5. Okay, so this is nothing but L by 10 you will get. If I take 10 LCM, you will get 5 minus 4. Okay, L by 10. So spring is elongated in this position. So this piston is in thermodynamic equilibrium. So net force is 0. So P2 into A, force from this side, is equal to KL by 10 plus P1 into A. This is first equation. Second equation is ideal gas equation for left chamber and right chamber. For left chamber, what is pressure? P1. So P1 into volume is V, let us say. This length is L by 2, that length is L by 2, so volume is same. So P1 into V, which is L by 2 into A, equal to number of moles 3 by 2 and nRT. 3 by 2 RT. Okay. T is same because it is a conducting piston. Vessel is adiabatic. Okay. Vessel is non-conducting, but piston is conducting. So temperature in both the chambers has to be same. Similarly, P2 into V equal to number of moles are 1. Okay. RT. So if I divide these two, I will get P1 by P2 is 3 by 2. So what is P1? 3 P2 by 2 will get. So in place of P1, if you put 3 P2 by 2 here, okay. In place of P1, if I divide both of them, what do you get? P1 by P2 is 3 by 2. Okay. So P1 is 3 P2 by 2. Oh, this P2 into A, this force. Okay. This is minus L. Okay. This force is P2 into A due to pressure on the in the chamber. Okay, due to pressure in this chamber, force is towards right and spring force is towards left. So this force plus spring force equal to force due to pressure in the left chamber. Okay, so here you will get here, but you can substitute P1 equal to 3P2 by A. Then what do you get here? P2 by A equal to KL by 10. So what is P2? KL A by 10 into 2. Okay, that's what it is. So KL A by 5 will get. So if it is in denominator, alpha equal to 5 will get. Okay, that's all. That's all. Okay, thank you.